Hi, welcome to another Level 3 probability distributions video. This would be our last video for binomial distribution, but we're going to split it up into 5A and 5B to do an example in each. So let's get into example 1. This is inverse binomial distribution. We've given a probability, we've got to work backwards to find some other parameter. So Lotto is selling packets of 10 scratch and win tickets, which I call scratchies. They claim that with 10 tickets, you are guaranteed to win at least one prize 99% of the time. We're going to calculate the probability of winning for each ticket. So we know N is 10, and we don't know P, the probability of success, or the probability of winning for each ticket. And therefore, if we don't know P, we also don't know Q, which is the probability of failure, the probability of not winning for each ticket. Don't get sucked in with this 99%. That's not P. This represents the probability of X being greater than or equal to 1, which is at winning at least one prize 99% of the time. So if I did my probability distribution table, X represents how many prizes you win. You could win no prize, one prize, two prize, all the way up to winning 10 prizes. And this 99% here represents winning at least one prize, so winning one or more prizes. So this is all these probabilities here will all add up to 99%. So I'm going to write down P of X greater than or equal to 1 is 0.99, and if I subtract that away from 100% or from 1, the decimal of 1 minus 0.99 leaves me 0.01. So the probability of X equal to 0, that's winning no prizes, is 0.01. So I can pop that up here in the missing box, and I know the probability of winning no prizes is 0.01, 1%. Now that's the number I need to carry on with the problem. All right, I'm going to write down my binomial distribution formula here. We've used it in a previous video, so if you're a little bit rusty, you have to go back and practice it. And I'm going to replace small x with 0 because that's the probability we know, the probability of winning no prizes. I'm going to replace n with 10. And I'm going to replace P. Actually, I don't know P, so I can't replace that. And I don't know Q, so I won't replace that either. All right, we're going to show you how to solve this equation. First thing is, we know that the probability of x0 is equal to 0.01, so I'm going to replace that with 0.01. I know 10C0 is equal to 1. I'll tell you why, because 10C0 is equal to the following formula. 10 factorial divided by 0 factorial times bracket 10 minus 0 factorial, which simplifies down to 10 factorial over 10 factorial. Remember, 0 factorial is defined as 1. Now, if you have 10 factorial over 10 factorial, that's just 1. Any number divided by itself is 1. So 10C0 just becomes 1. P to the power of 0 also becomes 1 because any number, doesn't matter what number, to the power of 0 is 1. So it doesn't matter what P is, when I raise it to the power of 0, it's 1. And Q to the power of 10 minus 0 is just Q to the power of 10. All right, well, this will simplify down to 0.01 is equal to Q to the power of 10. Let's pop this up on this side for a bit more space. Now we've got to figure out what Q is. To do that, we're going to take the 10th root of 0.01 to get Q. Now the 10th root, on our calculator, what you need to do is type in 10 and then look around for your xth root. It looks like a square root, but it's got an x out the front. And then type in 0.01. Now that should give you a value of 0.6310, and I've rounded that to 4 significant figures. So that's Q, that's the probability of failure, the probability of not winning on each ticket. So all I need to do now is subtract that away from 1, because I know P and Q add up to 1. If I subtract that off 1, I get P is 0.3690. And now I've solved the problem, I've found the probability of winning for each ticket, and I can write it as a percentage if I want, and my final statement will say the probability each ticket will win a prize is 36.9%. Thanks for watching.